Hello students, today class the learning objective is about chemical properties of amines. The chemical properties of amines, we have to read about the alkylation and the steric effect, alkylation, acylation, the different properties we are going to study in today's class. Phase transfer catalysis, these are the chemical properties today we are going to see. Alkylation, all the three types of amines react with alkyl halides to form quaternary ammonium salt as a final product, provided the alkyl halide is provided in excess. So coming to the chemical properties of the alkyl halides. So the amines are basic in nature, and amine salts, they act as the phase transfer catalysis. And the next chemical properties are alkylation, acylation, carbylamine reaction. All these will look on. Alkylation, all the three types of amines react with alkyl halides to form quaternary ammonium salt as the final product. And here the condition is we have to provide alkyl halide in excess. Here, ethylamine on reaction with ethyl bromide, HBr is removed and diethylamine is formed. Still, a nitrogen is having one hydrogen. The hydrogen again can react with one more alkyl halide. So again on reaction with ethyl bromide, triethylamine is formed. Triethylamine, further reaction with one more alkyl halide will give quaternary ammonium salt. So aromatic amines also undergo alkylation as given below. Alkylation can be done for the three types of amino acids. Three types of amines. So all the three types of amines react. The primary can react, secondary, tertiary can react, but not the quaternary. As the hydrogens are present, the amines will react with the alkyl halide. Now, even in the same way, the aromatic amines will react. Coming to the aromatic amines, this is the benzene ring having an H2. Aniline we call it as. Aniline on reaction with ethyl chloride, it gives ethyl aryl amine. And this nitrogen is having one more hydrogen. One more hydrogen is present. So one more alkyl halide can react. So ethyl aryl amine reacts with ethyl bromide to give diethyl aryl amine. This diethyl aryl amine further on reaction with ethyl halide gives triethyl anilinium bromide. Triethyl anilinium bromide is formed. Now we'll see the acylation. In the alkylation, we have seen for the alkyl halide as well as in the alkylation, this alkyl halide has reacted with the alkyl amine, and also the aryl amine has reacted with the alkyl halide. So primary, secondary, tertiary, quaternary salts of the ammonium are formed. Now we'll see The next one, acylation reaction. Acylation. Ethylamine on reaction with methanoyl chloride, acetyl chloride, in presence of base, ethylamine is formed. This ethylamine reacts. So HCl is removed, H and this chloride. It is removed in presence of base. Therefore, C2H5 and H bond CO bond CH3 is formed. This is acylation. For the amine group, the acyl group is added. That is called as the acylation reaction. Is the acylation reaction. Now, here we'll take one more example. Ethyl amine on reaction with methyl. Here, this is acetic anhydride. You call it as acetic anhydride. For acylation, there are two reagents that can be added. One is the acetyl chloride. The other one is the acetic anhydride. One is the acetyl chloride. The other one is the acetic anhydride. Okay, so for the first reaction, we have taken acetyl chloride, and for the second reaction, the acylation reagent is acetic anhydride. So one of the CH3CO group gets added here. Now we'll see how it takes place. C2H5 NH CO CH3 is added and CH3COOH is liberated. Here HCl is liberated. Now in this reaction acetic acid is liberated. So this is the acylation. Addition of acyl group to the amine is acylation. Addition of alkyl group to the amine is alkylation. Now what is benzoylation? Methylamine on reaction with benzoyl chloride in presence of pyridine. It gives CH3 and HCO C6H5. CH3 and H2 and C6H5CO Cl. HCl is removed and the CO C6H5 is added to the NH group. So this is Shorten-Baumann reaction, benzoylation. Benzoyl group is added. It is benzoylation. It is benzoylation reaction. Amine reacted with the benzoyl chloride. Now, this is Shorten-Baumann reaction. Benzoylation of aniline is called as Shorten-Baumann reaction. This compound, whatever it is formed, is benzanilide. Benzanilide is the compound formed in this reaction. Now, carbylamine reaction. In carbylamine reaction, only primary amines give this reaction. R and H2 on reaction with chloroform and 3KOH in presence of heat, Rn triple bond C is formed. Rn triple bond C is formed. Isocyanate is formed. A bad smelling agent, pungent smelling agent. So this carbylamine reaction is an important reaction for the detection of the primary amines. Primary amines on heating with chloroform, CHCl3 and KOH forms a foul smelling, bad smelling isocyanates. This reaction, it identifies primary amines. It is known as isocyanate test. Primary amine on reaction with CHCl3 and 3KOH, it gives RNC, 3KCl and water. Similarly, you can take the ethylamine also. In place this R and H2, we can take ethylamine. Ethylamine on reaction with chloroform and 3KOH, it gives ethyl isocyanide and 3KCl and water is formed. Similarly, aniline on heating with chloroform and KOH forms phenyl isocyanide. It forms phenyl isocyanide. C6H5NH2. Even we can react with the aromatic amines, aniline. Aniline also reacts with chloroform 3KOH. So primary aliphatic amine or primary aromatic amine can form this reaction, can undergo this reaction. So aniline on reaction with C6H5 and H2 is aniline. When that can react with chloroform 3KOH, and on heating it gives C6H5 bond NC, 3KCl is formed and 3H2 is formed. Now separation of the this one carbylamine test is a very peculiar test. MIC, methyl isocyanide gas, methyl isocyanide gas. CH3N double bond, C double bond, and further C double bond was. This was responsible for the Bhopal gas tragedy in December 1984. In December 1984, this is the gas, the tragedy is due to this gas. Now we'll see the reaction with nitrous acid. Reaction with the nitrous acid. RNH2 on reaction with HNO2 in presence of NaNO2 and HCl. Here RN2Cl, diazonium chloride is formed, and further on hydrolysis we get alcohol, nitrogen is liberated, and HCl is formed. So quantitative evolution of nitrogen is used in estimation of amino acids. It is used in the estimation of the amino acids and protons. Here you take the aniline, it reacts RNH2 in place. I am taking the aromatic amine RNH2, and it reacts with sodium nitrite and HCl at 273-278 Kelvin. C6H5N2Cl, benzene diazonium chloride is formed, and sodium chloride and even water is formed. But the secondary and tertiary amines react with nitrous acid in different medium. So let's have a look. The methylamine gives diethyl ether with HNO2. It forms diethyl ether with HNO2. Now reaction with aryl sulfonyl chloride. A very, very important reaction, Hinsberg reaction. This is the Hinsberg reaction. Reaction of the benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonyl amide. Okay, so the reaction of the benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonyl amide. So benzene sulfonyl chloride reacts with ethyl amine. It reacts with ethyl amine, and thereby you can see N-ethyl benzene sulfonyl amide is formed. It is soluble in alkali. So the reaction of benzene sulfonyl chloride with secondary amine yields N, N diethyl benzene sulfonamide. And coming to the reaction with Hinsberg reaction and reaction of the benzene sulfonyl chloride with tertiary amine. What it does? See, primary amine is reacting. Primary amine will react. The reaction of the benzene sulfonamide with primary amine yields N-ethyl benzene sulfonamide. N-ethyl benzene sulfonamide. This is the primary amine on reaction with benzene sulfonyl chloride. It gives N-ethyl benzene sulfonamide soluble in alkali. And when the secondary, see here, two ethyl groups are present, this is secondary amine. N, N diethyl amine on reaction with benzene sulfonyl chloride, it gives N, N diethyl benzene sulfonamide, and it is insoluble in alkali. Okay, so we can differentiate the amine now. And the third one is tertiary amine. There is will be no hydrogen. So there is no chance of reacting with benzene sulfonamide. In this way, you can differentiate primary, secondary, tertiary amines. So primary will give N-ethyl benzene sulfonamide, which is soluble in alkali. So once if solubility is there for the form compound, then that is primary amine. And for the second one, there is a reaction, but there is insolubility in alkali, and that is secondary amine. And for tertiary amine, there is no reaction at all due to absence of hydrogens. Okay, so therefore, this is tertiary amine. In this way, we can identify primary, secondary, tertiary. For primary, two hydrogens are present, so it undergoes reaction with benzene sulfonyl chloride as well as with alkali. And secondary amine, it is having only one hydrogen. It reacts with benzene sulfonyl chloride. It has no other hydrogen to react with the alkali. So it is insoluble in alkali. Coming to the tertiary amines, there are no hydrogens present. So it doesn't react with benzene sulfonyl chloride nor alkali. This way, we can differentiate. We can differentiate both the primary, secondary, and tertiary amines. Now we'll see reaction with aryl sulfonyl chloride. Reaction with aryl sulfonyl chloride. Already that was explained, sorry. Now we'll see the reaction with aldehydes. How it's reacting with the aldehydes. Skiff base. Reaction with aldehyde, skiff base is obtained. Here, aromatic amine on reaction with benzaldehyde in presence of zinc chloride, it forms benzidine aniline. Skiff base is formed. This is another reaction of the aniline. Coming to the next reaction, electrophilic substitution reaction. Aniline is ortho and para directing towards electrophilic substitutions. It is ortho as well as para directing towards the electrophilic substitutions due to high electron density at ortho and para positions. Now we'll see the reaction. Aniline, here you take the bromine, in presence of bromine water. In presence of bromine water, the tribromination takes place. 2,4,6 tribromoaniline light yellow pipette is formed with liberation of 3 moles of HBr. To prepare mono-substituted derivative, activating effect of NH2 group must be controlled. It can be done by protecting the NH2 group by acetylation with acetic anhydride. Now we'll see the reaction. Just have a look onto the reaction. Yeah, coming to the reaction. Aniline on reaction with acetic anhydride in presence of pyridine, it gives CO substitution at NH. It gives the hydrogen and acetic acid is liberated and COCH3 is getting substituted. benzanilide is formed. And this one further on reaction with the bromine, acetic acid, it gives BrNHCOCH3. Now this one on further reaction with the base or acid, it forms parabromoaniline. Parabromoaniline. So these are the electrophilic substitution reactions of the aniline. Aniline, it is the ortho-pair OP directing group. So electrophilic substitution reactions due to high electron density at ortho and para positions will take place. So on bromine water and bromination, the ortho-para positions are getting substituted with the bromine, the electrophile. And to prepare the mono-substituted derivatives also, the acting NH2 group must be controlled and it can be protected by NH2 by acetylation with acetic anhydride. So first we are protecting this one. NH2 group, it should be controlled, mono-substituted derivative. So this should be controlled and thereby protecting this group. Then we do the acetylation. So by protection with the acetylation, here it is getting protected. After protecting this group by reacting with acetic anhydride and pyridine, we have reacted with the bromine in presence of acetic acid. Thereby, the bromine is getting attached at the para position. Is getting attached at the para position. Bond NH2 and again bromine. In presence of base, this gets liberated back. The acetyl group, whatever is blocking, again it comes back. Whatever group it is getting blocked, that comes out. Okay, parabromoaniline is formed. Now we'll see the nitration direct. So nitration of the aniline is not possible as it is susceptible to oxidation. Thus, amino group is first protected by acetylation. The similar fashion, again the aniline, nitration of the aniline, it is not possible. And we have to protect the NH2 group because it is susceptible for oxidation. We have to protect this one and then we have to react with the acetyl group. So again with acetic anhydride and pyridine, the NH2 group is protected with the acetyl group and then we have to do the nitration. HNO3, H2SO4. So you get, at temperature, you get the nitro group substitution at the para position and thereby will relieve the protected group. The acetyl group is relieved by reacting with the OH and the H plus ion. In strong acidic medium, aniline is protonated as anilinium ion, which is meta-directing. So it gives meta products only. Now, the nitration is done. Aniline on react in presence of HNO3 and H2SO4 at 288 Kelvin, paranitroaniline and metanitroaniline, orthonitroaniline. All the three products are formed, but the percentage of the formation of the product is varying. Now we'll see the sulfonation. Here the sulfonation. On sulfonation, alanine gives sulfonalic acid as the major product. Aniline on reaction with sulfuric acid and further heating, we get sulfonic acid. Aniline sulfonic acid, which again indirectly zwitterion is formed, a plus and minus dipolar ion is formed. This is the zwitterion. Now, aniline does not undergo Friedel-Crafts reaction due to salt formation with aluminium chloride. The Lewis acid, which is used as the catalyst, due to this nitrogen of the aniline acquires positive charge and hence behave like the strong deactivating group for further chemical reaction. Now we'll see the oxidation reaction. Oxidation. Using different oxidizing agents, like different products will be formed for us. See, as I've told you, aniline doesn't undergo any Friedel-Crafts reactions due to the salt formation with aluminum chloride, that is a Lewis acid. It acts as a catalyst. So due to this, the nitrogen of the aniline acquires positive charge and hence it behaves like a strong deactivating group for further chemical reaction. Now we'll see the oxidation reactions, how it is different for the different oxidizing agents to give different products. Oxidizing agent is acidified KMnO4. You get aniline black, a dye. A dye is formed. So we are seeing in these reactions, reaction with sulfonyl chloride, reaction with aldehydes, electrophilic substitutions. In this electrophilic substitutions, first bromination is done, then nitration is done, and the third one is sulfonation is done. And these are the three electrophilic substitutions that are undergone by the aniline. Aromatic amines electrophilic substitutions we have seen. One is bromination, nitration, sulfonation. Okay, these are the three reactions. Now let us see the amines oxidation reaction. Amines on oxidation with KMnO4, amines on oxidation with the KMnO4, it gives different products. And amines on reaction with acidified KMnO4 or sodium chromate plus copper sulfate and dilute acid. Even this can act as the oxidizing agent. Aniline black is formed. Aniline black is formed. And similarly with the chromic acid, sodium chromate on reaction with sulfuric acid, we get parabenzoquinone. We get parabenzoquinone. Carose acid, H2SO5, carose acid. And this is also acts as the oxidizing agent. This oxidizing agent on oxidation with amines, it gives nitrobenzene and nitrosobenzene. Nitrobenzene and nitrosobenzene is formed. And on oxidation with the nitric acid, decomposes the decomposed product is formed. These are the oxidizing agents. So due to the slight disturbance, I'm repeating the oxidation once again. Oxidizing agent, if it is acidified KMnO4, amines give aniline black. Sodium chromate, copper sulfate, and dilute acid. And chromic acid, that is sodium chromate, and sulfuric acid gives parabenzoquinone. And carose acids, it forms nitrobenzene and nitrosobenzene. In presence of concentrated nitric acid, it decomposes. Okay. These are the reactions of the amines. Now let us see the separation of amines, that is mixture of the amines, how we are separating using that is the primary, secondary, tertiary amine separation. We'll see. The first one is the fractional distillation. This method, it is based on the boiling points of the amines and it is used satisfactorily in industry. It is used in satisfactorily in the industry. Hoffman's method, diethoxyoxalate is called Hoffman's reagent with which mixture of amines is treated. So separation of amines, primary, secondary, tertiary amines. For separation of amines, fractional distillation is done. This method it is based on the boiling points of the amines and it is used satisfactorily in the industry. For the Hoffman's method, diethyl oxalate is called the Hoffman's reagent with which mixture of amines are treated. So in that, primary amine forms solid dialkyl oxamide. Secondary amines form liquid dialkyl oxamyl ester. Tertiary amines do not react. Okay, so this is the separation reaction. Separation of the amines can be done by three methods: the fractional distillation, Hoffman method, and the third one is the Hinsberg method. So benzene sulfonyl chloride is treated in the and thereby alkali is treated with the amines and thereby they're distinguished. That reaction is called Hinsberg reaction. And the fractional distillation is based on the boiling points of the amines that are used in the industries. Hoffman's method, diethyl oxalate is called Hoffman's reagent, and using diethyl oxalate, the mixture of amines are treated. That is the Hoffman's method. And this is the way we separate the primary secondary amines. Next class, I'm going to tell you about the benzene diazonium chloride. Okay, today's class, we have seen previous class I have explained about the nomenclature and preparations. Today's class, I'm explaining you about the preparations of the, properties of the amines. So coming to the properties of the amines, we have seen preparations are completed and we have started with the chemical properties of the amines. The first one is the alkylation. That is the Hoffman reaction, as I've told you. Hoffman reaction on reaction with the alkyl halide. Excess of alkyl halide, it gives primary, secondary, tertiary substituted products. Now coming to the acylation. Ethylamine on reaction with acetyl chloride, acyl product is formed. Acylation can be done with acetyl chloride as well as acetic anhydride. Now, benzoylation. It is a Schotten-Baumann reaction. Benzanilide is formed on treatment with methylamine with benzoyl chloride. Now, coming to the carbylamine reaction. Amines on reaction with chloroform at 3 kOH gives isocyanide. Similarly, reaction with nitrous acids. Diazonium salt is formed, thereby alcohol is liberated, is formed. And ethylamine on reaction with NaNO2, HCl in presence of HCl 278 Kelvin, benzene diazonium chloride is formed. Now, the separation reaction, a very important reaction. Benzene on reaction with the aryl sulfonyl chloride. The primary will react with both alkali and benzene sulfonyl chloride. The secondary, it will react only with benzene sulfonyl chloride and doesn't react with alkali. And tertiary means does not react with the benzene sulfonyl chloride. These are the reactions of the benzene. So these are the reactions of the benzene sulfonyl chloride with amines. So this is how we can distinguish the primary, secondary, and tertiary amines. And the next one is reaction with aldehydes. So reaction with the aldehydes, as I've shown you. aniline on reaction with the benzaldehyde, it is giving benzalidine aniline. Benzalidine aniline is formed. In the electrophilic substitutions on reaction with the bromine, it has formed 2,4,6 tribromoaniline. Next, here the next one is the, as I've told you, electrophilic substitutions. One is bromination. Here, this is the bromoaniline is formed. The second one is the nitration product, nitro product of the aniline is formed. And the third one is the sulfonation, sulfonalic acid is formed. And the next chemical property is oxidation, I have seen, and separation of amines. So this is the end of today's class. Thank you, everybody.